Imagine a quiet evening in 1956. A family is gathered in their living room when the television's channels dial turns on its own. The volume spikes and drops, as if a poltergeist has taken over the electronics. The actual cause wasn't supernatural. It was often just the family dog scratching its ear, or the metallic jingle of a set of keys in someone's pocket. These hauntings were the side effects of early Zenith Space Command remotes. To avoid wires, these devices were engineered to trigger the TV using high-frequency ultrasonic sound waves, the same frequencies accidentally produced by jingling keys or a dog's metal collar. Controlling a machine from the couch meant taming invisible forces. But as early users discovered, teaching a television to listen only to its owner while ignoring the rest of a noisy world was a massive engineering hurdle. This effort to master distance began long before the television. In 1898, inventor Nikola Tesla stood before a small pool at Madison Square Garden, wielding a wooden box with a lever. By moving that lever, Tesla steered a toy boat without physical connection. Inside, a receiver with metal powder reacted to invisible radio waves. When the waves hit, the powder clumped together to complete a circuit, powering the boat's motor. The U.S. Navy initially dismissed the invention as a fragile toy. However, the desperation of 2 world wars changed that perspective. Seeking ways to strike from a distance, militaries refined Tesla's radio tech to create guided torpedoes steered toward enemy ships from miles away. Global conflict turned radio transmission from an experimental concept into a reliable, mass-producible technology. Once the wars ended, this military-grade tech was ready to be repurposed for the civilian home. The first consumer remote, 1950s Lazybones, was barely a remote at all. It was a long, thick cable running across the floor, which became such a frequent tripping hazard that it sent more people to the floor than it did to a new channel. Engineers then tried the Flashmatic, a wireless remote that beamed visible light at sensors on the TV. But they quickly found that afternoon sunlight or even a bright ceiling lamp would hit the sensors and accidentally trigger the channel dial. This led back to sound, specifically the battery-free Space Command. When a user pressed a button, a tiny mechanical hammer struck a miniature aluminum rod inside the remote. This emitted a high-frequency ultrasonic click that only the television was designed to hear. Because physical wires were dangerous, light was unreliable in the sun, and sound was hijacked by pets, engineers had to develop a more sophisticated, invisible language for the living room. The industry eventually settled on infrared technology. To prevent the TV from being confused by other light sources, remotes began using pulse code modulation, a method of turning light into a digital stream of ones and zeros. To bypass background interference, the remote acts like a high-speed strobe light, blinking 38,000 times every second. The TV receiver is tuned specifically to this 38 kHz frequency, allowing it to ignore the steady, non-blinking light from the sun or lamps. This digital stream handles specific commands, like distinguishing between a long press for channel 1 and 2 separate presses for channel 11. This is managed by a specific data block called the toggle bit. The toggle bit only flips its value from 0 to 1 when the user lifts their finger and presses the button a second time. If the bit doesn't change, the TV knows the button is simply being held down for a single command. These digital checks created a reliable, energy-efficient system, allowing a single remote to send dozens of unique, error-free commands from across a room. Despite its reliability, infrared has a major weakness. It requires a direct line of sight. It is essentially a beam of light, meaning it cannot pass through walls, solid wood cabinets, or even a person standing in the way. For devices like garage doors, engineers went back to radio frequencies. However, early RF remotes used a single static code. This was a security nightmare. A thief could record that signal with a basic receiver and play it back later to open the door. The solution was the rolling code algorithm. Every time the button is pressed, the remote generates a new code from 100 billion possibilities. The receiver only accepts the next expected code and immediately blocks the previous one, making any intercepted signal useless. Solving these security and line-of-sight issues turned the remote into an encrypted interface for our most sensitive household entry points. This newfound convenience changed how we lived in our homes. By removing the need to walk to the TV to change a channel or skip a commercial, The remote fostered a more sedentary lifestyle, famously personified by the couch potato. The remote also introduced channel surfing. Because changing the station was now effortless, viewers began clicking away the instant they felt a moment of boredom. Television producers, terrified of losing their audience to a single click, were forced to change how they made television. They sped up the editing, increased the pace of the action, and shortened scenes to ensure something new was always happening on screen. The remote didn't just change how we interacted with the TV, it forced the medium itself to move faster. Television content was redesigned to match the speed and impatience of the remote control. As the number of home electronics grew, so did the number of remotes, leading to cluttered coffee tables and complex universal controllers like the Sony Remote Commander, which were often overwhelming to use. Today, typing into a search bar with arrow keys is being replaced by voice AI. Natural language processing allows users to find a specific film across multiple streaming platforms in seconds simply by speaking to the device. This is evolving into a smart home ecosystem where machine learning tracks a user's habits. These systems can now adjust lighting and temperature automatically, acting without the need for a physical button press or a voice command. The trajectory that began with Tesla's 1898 wooden box is leading to the device's eventual disappearance. Control is no longer something we hold in our hands. It is becoming a predictive, integrated part of the environment itself.